Now, this is informative because it also tells us that that burning, that acidity that we feel, can inhibit the way that our muscles work, but that lactate comes in and allows our muscles to continue to function. That is lactate that's present to suppress the burn, to suppress acidity. It's also a fuel. When you feel that burn, lactate is shuttled to those areas of the muscle. Here's a reason that regardless of what kind of exercise you do, if it's weight training or running or cycling or swimming, that every once in a while, about 10% of the time, you should exercise to the point of intensity where you start to feel that so-called burn, right? So when I say that lactate acts as a hormonal signal, what I mean is that it's in a position to influence tissues that are outside of the muscle. Lactate will then provide additional fuel for additional work. It's not a signal to stop necessarily, and it can act as a hormonal signal. Lactate can then travel to the heart and to the liver and to the brain and can enhance their function in positive ways, not just in those moments, but in the period of time that follows. So put simply, if you're an exerciser, if you're doing movement of any kind and you're interested in allocating some of that movement toward enhancing brain, heart, and liver health, there is a nice set of scientific data that points to the fact that getting lactate shuttled to the muscles by engaging this burning sensation is advantageous for the health of those other tissues. But this process of lactate acting as a buffer, a fuel, and a positive hormonal signal for other tissues occurs only if there's oxygen. But most of the data point to the fact that hormonal signals, things that are transported in the blood during exercise, are what are beneficial for the brain, and that those signals are not causing the increase in the number of neurons in the dentate gyrus or otherwise.